Okay, as we do with the other problem, we have to put this in proper form. So what I need to do is I need to set x to be y, let's see, minus m minus 3 plus 3 over 3 plus 1. Plug it in. Before I do that, though, I want to point out this is an important substitution, and we hope it's going to produce what we expect it to produce. So let's write this down. Fairly easy to do. So what I'm going to do, I have to cube it first. That's going to be y cubed plus 3y squared plus 3y plus 1. That's done. Now it's going to be minus 3. Well, the x squared is going to be y squared plus 2y plus 1. I'll take care of that later. Minus 2x, which is, let's see, it'd be minus 2y minus 2, and then plus 1 equals 0. Let's go through the dirty work here. What do you get of simplification, by the way? Y cubed. I did this. Let's keep going. Let's see, 3y squared minus 3y squared, that's gone. 3y minus 6y. Let's see, 3 minus 6 is minus 3 minus 5. And let's do our number now. 1 minus 3 is minus 2 minus 4 minus 3. All right. I want to encourage you that before we go forward, we give you a key for a reason. And I want to see if we've got that, which is y cubed minus 5y minus 3. Now what do I have to do? I have to identify the a and the b. The a in this problem over here is going to be 5, and the b in this problem over here is going to be 3. All right? Now before you go forward, we do provide a picture for you, and I know my roots over here. You know, this root here roughly is 3 point something. I'm going to say about 3.6. Maybe I'm exaggerating that a bit. Maybe 3.5. This over here, I'm going to say about 0.4, about. And over here, I'm going to say about minus 0.8. All right? So what do we do now? Well, we got to compute that z business. And to write down the z for you again, what's the z going to be? And let's be careful. It's going to be arc cosine. Let's take a look. It's going to be b over 2. What's going to be 3 over 2? Root 27 over a cubed. And what's a? It's 5, so 125. All right? I'm not going to simplify because it really doesn't add much to it. Then you know you got to write these down. And what's going to be? It's not x, it's y. Again, we're using this depressed form. So what's y1 going to be? 2 square root of, and again, I'm not looking to simplify anything. What's the a again? That's going to be 5 over 3. And then it's going to be cosine of z over 3. What's next one going to be? y2 is going to be 2 root 5 over 3 cosine 2 pi plus z. Again, z is the number up here, over 3. And then y3 is going to be 2 root 5 over 3 cosine, let's see, 2 pi minus z over 3. And then you compute those numbers, all right? Let's just see if we've done a good job of identifying the a. I said 5 and 3. Whoops, sorry about that. Let's see if we got this down. And that's going to be 3 over 2. Yep, we got that down. And then we put this stuff down to, yeah, we did. We just didn't compute the numbers. The reason being, they're nasty to compute. I definitely do recommend using a computer to do that. You get a number, you get a number, you get a number. Now, some people say, oh, that must be the answer. That is not the answer. Someone says, I have to remember. Well, what do you have to do? You have to take y and add 1 to it, which is relatively simple to do, by the way. You take each of these numbers, add 1 to it. What would you get? Let's go through that. If you took this number here, add 1 to it, you get 3 point something. If you took this number, add to it, you get minus 0 point something. If you took 1 to add to that, a little more difficult, by the way, you're going to get point something, all right? Now, I want to go back to the graph and tell you that I looked at it. Remember, I said roughly 3.5. Well, it is roughly 3.5. What did I say over there? I said roughly about 0.4. Well, you know what? I was pretty off in that one. This is 0.34. It, maybe within reason about, like if I was saying someone, 34 or 40, you get the idea. It's not that far off. Although someone might be offended if I did say that to them. And then over here, I said roughly about minus 0.8. I made a mistake. Oh, no, I'm sorry, I did make a mistake. It's right over here. Sorry about that. So they're all in line with what we expected to see, all right? So again, I'm going to recommend in these type problems, they're numerical in nature. We can get exact answers, by the way. What do you mean numerical in nature is we're actually computing an approximate number for these. How do I do that? I need a calculator. I can't say it enough times, though. Make sure you're in radian mode. If your calculator switches degrees, you're going to get bad answers. And you should know you're getting bad answers when you look at your graph. You'll know you got a bad answer, all right? So 2 problems, straightforward. The last 2 problems, I had to transform it into a depressed cubic so I could use the formula. And that took time and effort. And you know what? Mistakes happen. Make sure you look over that. When I say mistakes happen, I make mistakes. If you think I made a mistake somewhere in the written document, please reach out to me. My email address is Bannon, B as in boy, at nnon.us. And I'll do my best to help you out. Thank you.